Hey guys, and welcome to the Chemistry Shack. In this video, we will be making aluminum oxide. But before I begin the experiment, I want to thank all my subscribers for helping me pass the 1,000 subscribers milestone. When I first started this channel, I thought I would be lucky to reach 100 subscribers, but seeing that over 1,000 people enjoy watching my videos is absolutely incredible. And speaking of this, I actually don't have a 1,000 subscriber video planned because I want your input. I've listed a few ideas I did have in the description, so feel free to vote for one of those or suggest your own idea. Anyway, let's get on to the experiment. Aluminum oxide is a useful catalyst, and I will be using it in a future video to catalyze the dehydration of ethanol. For every gram of aluminum oxide you want to make, measure out 0.529 grams of aluminum foil, 5.66 milliliters of 31.45% hydrochloric acid, and 5.66 grams of sodium carbonate. Since I want to make 10 grams of aluminum oxide, I have measured out 5.29 grams of aluminum foil, 56.6 milliliters of 31.45% hydrochloric acid, and 35 grams of sodium carbonate. Put the sodium carbonate aside for now since we won't need it in the first step. We first need to dissolve the aluminum in hydrochloric acid to make a solution of aluminum chloride. So dilute the acid by adding the same volume of water and slowly add the aluminum foil. This reaction produces a lot of hydrogen chloride fumes, so do it outside or in a fume hood. Continue adding aluminum foil to the hydrochloric acid until all of the aluminum has dissolved. After all the aluminum has dissolved, the solution contains aluminum chloride, but it is full of insoluble impurities. To remove the impurities, filter the solution. After filtering, you'll be left with a nice clear solution, and all the impurities will remain in the filter paper. Now we're ready to convert this aluminum chloride into aluminum oxide. To do this, slowly add the sodium carbonate to the aluminum chloride solution. Carbon dioxide gas will be released and aluminum oxide will precipitate out as a gelatinous solid. We are using an excess of sodium carbonate to ensure that all of the aluminum chloride reacts. As you can see, the suspension is really thick and gelatinous, and so filtering it would take forever. Instead, add the aluminum oxide to a large volume of water and wait for the suspension to settle. This step serves to remove sodium chloride, the side product of this reaction, from the aluminum oxide. Sodium chloride is soluble in water, so it can be easily removed by washing the mixture with a lot of water. Aluminum oxide, on the other hand, will not dissolve in the water. After the mixture settles, decant off the water and leave the aluminum oxide in the beaker. Then wash the aluminum oxide 2 more times with water, decanting the liquid after each washing. These extra washings will ensure settle out of the water very well, so after the last washing, I poured off the upper layer that contained mostly water and only a small amount of aluminum oxide. I then scraped the rest of the aluminum oxide on the bottom of the beaker into a lab dish and dried this in an oven at 150 Celsius. After a couple of hours, we have a nice dry aluminum oxide powder. I weighed this and found it to be about 5 grams. As for the rest of the aluminum oxide, this was left in an aluminum tray for a couple of weeks until it completely evaporated. However, when I weighed this, the mass was almost 23 grams. Since the theoretical yield of aluminum oxide is only 10 grams, something went wrong. Either this is a hydrated form of aluminum oxide, meaning it contains water, or it is extremely impure. Either way, it probably won't work very well for the dehydration of ethanol. Fortunately, I have already tested the 5-gram sample of aluminum oxide and confirmed that it works for the dehydration of ethanol. Well, that's it for this video. Thanks for watching, and I hope you enjoyed it. Also, don't forget to let me know in the comments about what you want me to do for my 1,000 subscriber special video. Until then, thanks for watching.